Question is from GET 2023. Question is asked from numerical analysis. Let's see quickly what the question says. The question has given that mx equal to b. They have given m. They have given v. Now they have also said that m is equal to lu, right? And lu lower triangular matrix and u is the upper triangular matrix. Now this says that for the lower triangular matrix L, if the main diagonal element of L is 1, then trace of U is 3. We have to verify this statement. If the statement P is Q or not, statement P is true or not. See, this is the options. P is true or not, Q is true or not. Okay, so let's see first. P is true or not. So they have said that M is equal to LU, and they have said also that L should be in this form because the main diagonal of L should be 1, right? So this is your L and this is your U. Okay, so now just to m is equal to lu, so lu just now multiply lu into u, you will get this result. Now just compare this, you will get 2 is equal to d, you will get minus 1 is equal to e, you will get minus 4 is equal to cd, and 3 is equal to 3 plus f, right? So uh, d is equal to 2 and you have e is equal to minus 1, and cd is equal to minus 4, c is equal to minus 2 because d is equal to 2, and from here c is equal to f, c is minus 2, e is minus 1, so you will get 2 plus f equal to 3, and from here you will get f equal to 1, and you get your matrix u. Now if this u, you can now check what is trace of u. Trace means the sum of the diagonal element, right? So it is diagonal element 2, this is 1, so trace is 2 plus 1 equal to 3, so statement P is right. So this is your statement P, so it should be correct. Now let's verify now what the statement Q said. It says for any choice of the initial vector x naught, the Jacobi iterates xk. This converges to a unique solution. Okay. Now let's how we will do that. Okay. So for this, first we will check that this matrix M is diagonally dominant or not. If the matrix M is diagonally dominant, then this result true. But if this is a sufficient condition, okay, if M is diagonally dominant, then this result hold. This is a sufficient condition. But if M is not diagonally dominant, then we can't say anything, we just be silent. So but what the meaning of diagonally dominant, right? Do you know? uh, Let me show you. A diagonally dominant matrix means it should hold this result. For every I, ai mod of ai should be greater than summation I not equal to j is from 1 to n mod of aij. What that means? That means if you take any row, take the diagonal element of that row, take the modulus of that element, and see this is greater than sum of the modulus sum of the modulus of the rest element or not. If the diagonal element is strictly greater than this element for all the row, then you will say that the matrix is diagonally dominant. So let's check here that for this matrix M is diagonally dominant or not. So see, the matrix M, the diagonal element is what, 2 and 3. So mod of 2 is greater than mod of minus 1, right? So 1 is true, but mod of 3 is not greater than mod of minus 1, minus 4. So the matrix is not diagonally dominant. So in the statement, I already said you that if the result is not true, that M is not diagonally dominant, then we can't say anything about the convergence. Okay. So now what will you do? Now we will do one thing. We will see a necessary and sufficient condition. It says that for the linear system mx equal to b, if you can iterate a matrix, a iteration matrix T looks like this: minus D inverse L plus U. What is D, what is L, and what is U? D is the diagonal element, sorry, diagonal matrix of M. Do you know what that means? That means if your matrix is this, suppose this is M, okay? Suppose this is M, then your D will be the only diagonal element of this matrix, that is A and D. Rest of the element are 0. L is what? L is the lower component only, that is here C. and use the only upper component and the rest of the element is 0. So like this you have to take D, L and U. So if this iteration matrix T is like this, then if you can, you have to check that what is the spectral radius of T. Spectral radius means the absolute value of the largest eigenvalue. That means you have to take, you have to find the eigenvalue of T, and you will see that all the eigenvalues of that is strictly less than 1 or not. The absolute value of the eigenvalue. Okay. So let's do this for this our question. So here M is this. So for this M, what will our D? What will be our D? Our D will be this. This will be our L. This will be our U. Now we have to take T matrix T. So what will be the iteration matrix T? T will be minus D inverse L plus U. So this is, if this is D, then D inverse will be what? 1 by 6, 3, 0, 0, 2. So 1 by 6. So that means this will be your D inverse. Okay. You can do this by yourself, and this will be L plus U. After this, you can calculate the matrix T. The matrix T will be this. Okay. So now what the statement says? The statement says you have to check the eigenvalue of this matrix. Okay. So now you can find the eigenvalue of this matrix T, right? You have the matrix T is this. So eigenvalue of this matrix will be this, root over of 2 by 3 and root over of minus 2 by 3. Now the spectral radius means what? The largest eigenvalue, absolute value of the largest eigenvalue. So here both the, if you take the mod of this lambda 1, mod of lambda 2, then both lambda 1 and lambda 2 are same actually. Okay. So its largest eigenvalue will be actually root over of 2 by 3. Okay. So which is strictly less than 1, right? So from this necessary and sufficient condition, it says if this spectral radius is strictly less than 1, then for any choice of the initial vector, this Jacobi method converges to the unique solution. Okay. Now let me show you something. You can take a screenshot of this. How we take D, L and U. Okay. We will take M is equal to D plus M is equal to D plus L plus U. Then we will take Mx equal to B. Now Mx equal to B, M is equal to D plus L plus U. Put this value of M here and you will get this, and from there you will get the matrix T. Okay. I think you can do by yourself this. So from here we already got our answer, right? That it will converge from the necessary and sufficient condition. So both the statement is right. That means option A is right. Okay. I hope you understand the video. Uh, just subscribe the channel. I will upload also the rest of the solution of GET.